Hello and thank you for joining today's ROGII session. My name is Ali, and I'm a technical analyst based in Calgary office. And I'm joined today by my colleague Asim, who's dialing in from Houston. And both of us are excited to walk you through to the two of ROGII's integrated solutions that enhance drilling performance through a deeper understanding of subsurface. We will talk about StarSteer and DrillSpot. Our session today is focused on geology-driven drilling optimization and why it's more than critical for geologists and drilling engineers to work collaboratively in a unified environment. So let's dive in. Here's the agenda for today. I'm going to start with some of the workflows in StarSteer, starting with well planning, mapping, well correlation, and the geosteering operations. We will also see how some of the drilling workflows could be integrated inside StarSteer. And then Asim is going to talk about drilling operations monitoring and hazard identification, drilling parameters roadmap, ellipse of uncertainty, KPI monitoring, and geology insights. Asim, could you keep admitting more people as they join in? So yeah, please keep admitting more people as they join. So we'll start with an overview of ROGII's product ecosystem, which is designed to support full well lifecycle, from live rig data acquisition to real-time monitoring, data management, geological interpretations, and drilling optimization. Our cloud-based tools bring geoscientists and drillers together in a multidisciplinary, collaborative workspace. The tools that we are going to focus on today are StarSteer, which is our flagship geoscience platform that helps you do all the required workflows in the geoscience space. And we will also talk about DrillSpot, which is a web-based solution that brings geos and drillers onto a shared platform where they can do collaborative decision-making, risk reduction, and optimal wellbore placement. So why geology should drive drilling optimization? Let's look at some of the reasons why it is important to do so. So first off, better subsurface understanding enables smarter drilling decisions. Knowing the structure and stratigraphy upfront leads to smarter well planning. Geohazard awareness reduces risk. Knowing what geological hazards are coming in provide us geological insights, which avoids zones with instability, lost circulation, or abnormal subsurface pressures. The real-time collaboration speeds up decision-making. Tops and targets evolve. They are not always as planned, and the actual tops and targets keep moving. A shared platform ensures that both teams can adapt and align on the fly as we are drilling. And finally, a precise placement is equal to higher production. Landing the wellbore in the reservoir sweet spot can increase ROP performance, reduce non-productive time, and boost hydrocarbon recovery. So now we are going to look at what do the geologists do in StarSteer. So I will bring one of the projects in StarSteer on the screen. So starting from planning stakes, it is quite intuitive and very easy to plan your stake areas. You can create new areas, choose your number of sticks, buffers. You can adapt the areas to a particular shape of the leaves. You can choose the interactively choose the buffer area, stick lengths, azimuth, all those things in quite an interactive fashion. You can see that StarSteer does lots of the work for you. It calculates the distance between sticks, um, lets you put a particular spacing between the sticks. You can choose the stick count, uh, change the direction of the sticks um, to go in a particular azimuth or have them at a particular TVD subsea. So it is quite intuitive, and that's how the geologists start the planning process. Once they're happy, um, they can assign a common surface location just easily like this, and then um, using the stick operations, they can place these sticks in between particular geological structures. So I have already created a stick and created a well plan out of it. So I'm not going to uh, in detail of the workflow, but the gist of the matter is like this is how easy it is to start well planning, create a well plan uh, which has all the information that is required for the well planners to further enhance the well plan. So it includes the surface hole location, the whole trajectory, passing through the landing point and going to all the targets. So pretty easy and intuitive process to plan the wells, plan the sticks, and then create well plans out of these. Next off, the geologist also create several geological maps to better understand um, the geology. So I'm just showing you one, for example, that shows you how the structure is uh, at different depth intervals. You can also use uh, the property mapping to plot some of the geological um, properties, such as I used the ROPs for like 100 plus wells and created an ROP map for a particular zone interval. So uh, when I'm planning new wells based on the location, I can actually predict what would be the average ROPs while drilling into a particular area. So that was about structural mapping. The next thing that geologists usually do is correlating different wells. So I'm bringing StarSteer here. So here you can see uh, a correlation panel built, which has like a subject well compared to or correlated to several of the offset wells, and you can actually pick formation tops, relate different geological properties and drilling um, information from well to well, and you can actually correlate on how it is performing or how the geological properties are changing from well to well. So here is an example of well correlation where you can view in different scales, be it MD, TVD, subsea, or true vertical thickness, and you can correlate all the wells in any of these scales. And finally, um, here's the process of like geosteering, where let me just give it a few seconds. It's a little bit laggy because I'm presenting it on the Teams. that didn't like it, so let me show it on another. Okay, got it. So the geosteering process involves getting real-time data streamed in, and the geologists are actually monitoring the position of wellbore with respect to different surfaces, and they are creating target lines, which they can actually share in share with the drilling team as they go. So here, if the geologist changes their target, uh, DrillSpot enables um, the drilling team to view the same thing uh, in like real time, and the same uh, target lines are viewed in the drill spots. Let's give it a second to load. So here actually we view the same screen um, as stars here, where we've identified different formations and those target lines are updated here. So any changes made in stars here with respect to formation tops or target lines, the changes are reflected in real time in the drill spot. And drillers can then make decisions uh, in the real time. So now let's look at a few examples of bringing in some drilling related information, making use of different uh, features of star steer. So here I've got a well, and I just brought in some bit run data and imported those as formation tops. So I can now display at what depth each bit and BHA went into the hole, and I can display that along the wellbore paths. I can also view this information in a correlation panel, and using zones and attributes, I can actually bring in the bit hours for and BHA hours for each of the runs and display them in the real time. Using some of the information from DrillSpot, especially the slide sheet, I can actually display information such as rotary sliding and sliding for azimuth or sliding for inclination along the wellbore path. So this helps me analyze in real time on what the BHA is doing and how it is interacting with the rock downhole. So we can also use some drilling information such as vibrational logs, such as this one. Here we are plotting ROP versus lateral shocks, axial shocks, stick and slip, MSC, and bit hours. So when we compare different wells which are drilled in similar formations, we can actually identify zones of higher ROP and relate that to lower MSE and lower vibrations, more stable bits and BHAs. So star steer helps us identify all those sorts of uh, features and drilling parameters. So by monitoring and analyzing these data sets, geologists can recommend preferred rock layers. So let's see this example. For example, if in star steer we have like, if we divide into 1 feet or 1 meter interval, our target formation, we can actually identify which of the rock layers are drilling faster in terms of ROP and based on the gas data trends. And we can guide our wellbore trajectory to stay within the sweet spot of higher performance. Now I'm going to pass over to Asim to show us some great features in DrillSpot. So over to you, Asim.
Thank you, Ali. Hello, everybody. And that was a fantastic idea on how well planning and parameter comparison you can do within star steer. For DrillSpot, we are going to take some of the information that was over that Ali showed, and I'm going to show my own project for that matter, and going that, and then we'll go over some of the other features that are available for the DrillSpot side. So let me share my screen. Okay, Ali, you can see my screen?
Yes.
Okay, thank you. So as Ali mentioned,
Yes.
sorry. Uh, as Ali mentioned in the beginning of it, DrillSpot is a web-based application. It is part of our Solo Cloud ecosystem. So you can see on our landing page where we have our DrillSpot along with other few applications that are available to view and analyze the same data that is stored within the cloud database, what you call Solo. We also have a little boss dashboard over here, which kind of gives you an idea of the different wells that are drilling at the moment, along with their drill statuses. At the same time, it also kind of gives you an idea that, hey, if some of the bits.ml transmission is stopped, then it also gives a message saying that it's significantly delayed as of right now. One of the things with DrillSpot has been that, well, it was built in with the fact that real-time monitoring and decision making be done while the geosteering operations are going on. Many times the operations happens on site or remotely, and some of the operations are conveyed to the drilling team as reports or just screenshots. With DrillSpot as such, what we have over here is a real-time collaboration between the drilling data coming straight from the rig, along with the geosteering data that is coming straight from the star steer as such. So what I want to do for this DrillSpot is essentially give you an idea of how our real-time monitoring tools and optimization can be used in a pre-drill sense in the beginning, and how when the actual well is drilling, they are utilized. So, in the beginning, when Ali was showing the star steer, we, we had a well plan which was created, and along with, some of the offset wells that were part of the project. Uh, when we see it on the DrillSpot side, we can actually see the actual well plan. We can see the offset wells along with their ellipse of uncertainty. We can see that what was the target line used, well plan used for the nearest offset well, which in this case is the offset 1. We can also visualize this same data in a map view where you can see the 2 type wells. At the same time, you can see the 3 drilled wells, which are over here. And then this in the white over here is the planned well along with our 3 offset wells. So looking at the data, it is that we are going to be drilling the well. The planned well is slotted to be drilled in offset well. And the instructions were that we are going to use this target the same geology over there as in offset 1. So here I turn on the interpretations that are coming straight from the star steer. And we see that within this offset 1, the nearest well that is to be taken as for the planned well, we are targeting the lower for part of the top F as such. And we can see how that offset 1 was drilled along with their ellipses as such. Now, one of the things with DrillSpot is that it accesses the same data that is coming, that is in the Solo Cloud, and it is integrating that geologic data with your drilling data. So now, if I want to see how it was going on in the offset 1, I can just come over here. And for the ease of this course, for this webinar, I am kind of setting up these dashboards and duplicates so that it becomes easy to show. But at the same time, what I want to show is the different tools and widgets that are available and be, for your convenience. So as I said, like, the data, the drilling data and the geologic data are both residing on your drilling on the Solo Cloud database. And there the integration between them is quite easy and quite fast. So we're going to be targeting, going back to this, we are going to, for this purpose, we're going to target this the curve and the landing section for this well. And we see in the offset one that the two formations drilled over there were top E and top F before we landed the well in well target top. We have all this drilling data that is been brought in by WITSML, and we see the real-time tops that were interpreted while geosteering the offset one as such. We also see a days versus depth curve over here, which also integrates the same geologic data. And we can see it, we can look at it at both the wells to understand, okay, how much time was spent while drilling the top E and top F. We can use, say, filter it out by saying, I just want to see the drilling days. And so it kind of gives you an idea, okay, which well drilled faster as such. And we can see that the offset 2 was a little bit more faster in the landing and curve section in as compared to the offset 1, which was about 20 or half a day slower as such. And then we also have some of the KPIs to kind of give me an idea, okay, how was the rig performance when the offset 1 was drilling this landing section. So we can see that the slip to slip connection times were like around 3 minutes, while the target was about 1 minute, and get an idea of what our invisible loss time is. So the point in having all this data and in front of you is that it helps you in your well planning as such. It gives you an idea what were the formations drilled, how was the drilling performance, what was the rig performance. It also gives you an idea of your what kind of downhole hazards were observed as such or were kind of detected based on the drilling data as such. And it also gives you an idea as to what was the rig activity as such. So these are all based on our own algorithm. So where we can see, okay, when we started the top E, when we started the curve section, we were pretty much sliding for a while. Then as we entered the mid of the top F, we were rotating for a while. And we can see some of the other parameters like downhole MSC, total MSCs that are calculated within DrillSpot, along with their subsurface logs, some of the zeroed weight on bit. So it gives you a nice comprehensive idea of how the real-time operations happened when that well was actually drilled, whenever it was drilled as such. This is the part where you're kind of just visualizing the drilling data with respect to your geology and getting more insights based on some of the inbuilt algorithms within DrillSpot. One of the main things that you want to do with this data is we also be able to understand how fast can I drill, what kind of drilling parameters can I use, and you have your BHAs and bits for those offset wells. So just considering the same section that we are looking at, we see that we were drilling in the top E anywhere from 50 to 140 feet per hour, while in the top F looks like somewhere in the mid we kind of picked up the ROP, but we also see that our weight on bit was increased a bit over here. So there was definitely a change of parameters. So this can basically help you and say, okay, did we make but we don't see any kind of bit trip during that in the top, in the offset well. So what looks like it was based on how the drilling went and looking at weight on bit surface RPM and other traces, we can kind of visualize, okay, what kind of parameters need to be applied to get the same kind of ROPs within the planned well as such. The other way to look at that data is also in the more traditional way is, there it is looking at your crossplots. So here I can say, okay, I don't want to see, I just want to see top E and top F. And I'll do the same thing over here. I'll say I will select just top E and top F. And then I can say, okay, so it looks like for our ROP to zero weight on bit, we can roughly say that it was close to the best optimum parameters based on the FSET data is roughly around 105 to 200 feet per hour, and the weight on bit is roughly around about 10 to 12,000 pounds. And similarly, when we are looking at our other offset too well, we notice that we're putting a little bit lot more weight over here, and we were seeing roughly a little bit more ROP compared to the offset one. Now, the same data can also be seen in MD spends as such. And here you can see that we can apply the same filter as such. And we see that the maximum ROP was like 240. And we could say that it was close to 75. And the same thing with this, where we say, okay, while drilling the landing section, we observed somewhere around about 99 to 110 feet per hour. So the main part of this is that all these analytics tools is readily there. It's taking the data that is already available for you within the Solo Cloud database, and it is putting it in front of you to rightly, right away do your analysis. You don't have to take this data and put in some third application. You can get a quick idea of your operations as such, take numbers from it, and use in your drilling plan as such. So the value behind that is essentially making that process a bit more faster, to where you are not trying to extract data from some other source, putting in a different application, while you can use different geological interpretations or different geological filters within DrillSpot to kind of give you an idea, okay, what was my performance when I was drilling such and such formations as such. So this is kind of based on the pre-drill idea of what can be done with the available tools within the DrillSpot uh, application. Now let's talk about the real-time part as such. The well that is being drilled. So here's our, so what we looked was the planned well now, and here's our active well over here. This active well is mapped to the feed to the WITSML source coming from any of your sources that you have. So you have option to bring data by WITSML. You can bring data by ROGII's own hardware and software solution called SoloBox. And we can also bring some other drilling data hubs like from Payson and NOV, or service servers like from your SQC or MacWar as such. And the data can be brought in WITSML. It can be streamed to your star steers. It can be streamed to your DrillSpot traces with auto mapping and everything. So the process is very simple and quite fast, to be honest. Once the data is mapped, then as the real-time geosteering is happening, as the real-time drilling is happening, those stops will start showing up. In the beginning, it will start with little tops under the well plan. And as the tops are intersected and interpreted, then those tops will take precedence over the pre-drill one. And now you can see over here, as the real-time operations is happening, you can see what was the operations like, where we were sliding, what was the downhole hazards detected, like drag over here, which was like about 13% more than what was the benchmarked hook load at the previous connection. Here it is only like 8%. And you can also bring in your zero differential. And so at the same time, you can see your geosteering interpretation from the star steer. So here you have your target line, your well plan, you have your real-time trajectory along with your real-time ellipse of uncertainty. You also have your target tops and target base, the windows. You can have your other interpreted horizons. It gives you some idea about different kind of, oops, sorry, stats in the in the ribbon below over here. And at the same time, you can see the data in the map view as such. So this is from the drilling point of view, where the operations are happening. The geologists are making their interpretations in real time, and with straight away easy integration with the geology from StarSteer, you can visualize your drilling data as the operation, as with respect to the geology as they're happening in real time as such. The same data can also be viewed in a depth view. So here we have the same logs in depth view. Here you have the mud logs coming in, which kind of gives you an idea of what was the drill formation. You also have your same rig activity that we had seen in the previous slide over here, which kind of tells you where we were sliding, where we were rotating as such. And then you have your real-time days versus depth that to compare against your two offset wells that we saw in the pre-drill panel, along with the same geosteering window. So data visualization is one of the main things for real-time collaboration that is very important. And with DrillSpot, that part becomes very easy. You don't need to use any API. You don't have to do any drag and drops for LAS files into separate applications. And you can do it right away straight within DrillSpot. Now, one part we haven't talked about is the real-time optimization about it. Okay. And this is where the same panel that we saw in the pre-drill part is now being used to select to see what your active well is doing. So here we have our three offset wells for the landing curve. Oops. Okay, there you go. So, we have our landing section. We are drilling the top E, we have drilled the top F, we landed the well in the well, or we're landing in the well target. You can see your active well over here. You can see your three offset wells. And the data is actually taking the offset data, is the drilling data in the offset well is actually scaled to the current location based on the geology. It is basically taking the drill data within this top E and within this top F, and it is scaling to the active well by stretching or squeezing the data to where now you can get a apples to apple comparison within the drilled interval on the active well. So here you can see that for the top E, we are pretty much close we are pretty much drilling as what the offset was for showing. We have our own roadmap, the automated roadmap, which kind of gives you an idea what a single value should be for comparison. But you also have your heat map over here, which tells you based on the data density as to how much, how much of the drill data was actually falling within that parameter. So here you can see like 50% of the drill data was close to, oops, there you go, with 150 feet per hour. And you can see like you're a little bit slower over here as compared to what was in the heat map and roadmap. But as in the same thing you can be seeing over here in your top F, where you're closely following it to your roadmap as well as to the what is the heat map telling you as such. And then where you have operations, when you have your ROP slower, you can then come across your drilling parameters and say, okay, what is the reason behind the slow ROP? Is it because we are Is it because the geology, or is it we're not putting too much, enough weight on bit, or we're not rotating the pipe? Now, what we have over here is that when we do the scaling of this data, we don't take into consideration the sliding as such. We only bring the data which is rotating as such. And so it kind of takes out some of the anomaly which might be brought in during the sliding as such. And this kind of gives you an idea, okay, that when we are rotating, we're not putting that much amount of weight on bit, and we have a bit of a slower ROP. So maybe the driller can go ahead and start putting a little bit more weight on bit to say about 30 more thousand pounds as such, and he might be able to get the same faster ROP that we saw in the offset wells as such. The same data can, now this is in MD space, but we can also see it in TVT space, which is really useful when we are doing laterals. So in the lateral part where we have, so I can just say, okay, I just want to see last 1,000 feet of my lateral drill. And I'll just do my scale again. And now I can see that when in the lateral section, my active ROP is pretty close to the roadmap. It's a little bit higher than the roadmap, and it is even better doing than what was in the offset wells. So again, the same principle was applies is if the drilling performance is low, it gives you a right away instant idea as to what is the reason behind it. Is it we're not applying better parameters, or is it the rock which is causing the slowness as such? The same data in real time can also be observed on our live cross plots, where we can select real time filters to say, okay, how is my real time data doing with respect, when drilling those certain formations. Same thing can be applied to, with different cross relations like surface RPM versus weight on bit, ROP versus weight on bit. You can bring your own vibrational data into it. You can look at that. You can do comparison also about it. And from comparison point of view, we have a little workflow over here where, okay, let's see if this pops up. There you go. Thank you. So same formation that we were looking at, the top E and top F over here, we can now compare in real time across this dashboard. We can see, okay, how was the performance in offset 1? How was our performance in offset 2? How is it doing in 3? And then as the real time data plots in, you can sort of start getting an idea, okay, are we hitting certain optimum parameters? Are we slowing down? We see over here that we are drilling quite close to, it's like offset 1 and offset 3 are pretty close when it looks to trends. But when it comes to offset 2, we are a little bit more slower as such. So these are kind of the inferred solution ideas that you can get from your real-time cross plots as the drilling is happening and interpretations are made. Again, as the interpretations are changed on the star steer side, so will the data will change based on what the current interpretation is. The last part of it is rig performance. So again, here we have our own algorithm to determine the KPIs, and we can see our connection times, we can see our weight to weight times, and here we can see, okay, performance wise, how are we doing? Looks like we are doing well as compared to what the rig was doing on the offset 1. What was our invisible loss times? What was, the median for the connection times and everything. And again, we can break down the KPIs by night tower and day tower as such. So it kind of gives you an idea that, hey, these guys are pretty fast at night, must be the cool weather. Or, they're taking sweet time during the daytime because of hot weather. At the end of it, so DrillSpot, as Ali said and we've been saying, is that it is basically a real-time integration and collaboration of drilling data and geology data as it is happening. It can be used in pre-drill sense to give you a quick idea of how the operations were in your offset wells. At the same time, it can give you a quick idea of how the operation is happening in real time. And it can also give you some good in-depth analysis as to where we can improve our performance and optimize it, to where you can go and instantly talk to the drillers, share the screen. They could have the same screen running on their end and be able to communicate fast and make quick decisions as the operations happen. Uh, with that, I would like to open the floor to any questions. Oh, I just saw the questions.
Asim, let us quickly show how the collaboration works. So if
Mhm.
you would just maximize your geo target for active well, yeah, this one. So I have got the same project open on StarSteer on my end. So I am now going to make few changes on uh, StarSteer, and let's see how quickly they are reflected. So I just moved my target line on StarSteer, and you could see the change was reflected here in the real time. So I will make another small change. Let's say I got a geological fault and I want to update my interpretation. So you see the fault was created on the drill spot side simultaneously. So this is how drilling engineers and geologists can work in a collaborative environment. So drillers see what the geos are doing in StarSteer, and geos can see what uh, the drillers are doing in the real time as well. So thanks a lot, Asim. Appreciate the discussion. Now let's get to the questions part. If you guys have any questions, feel free mute yourself, ask questions, or write them in the chat window for Teams.
Hello.
Hi.
Yes, please go ahead.
Yeah, I have a question regarding optimization of performance.
Mhm.
And
Yeah.
there's the optimization is just by comparing well to well, section to section. So there's some mathematical processing. Like, if you understand what I'm asking.
Yeah. So it is basically it is on well to well basis, but we are not just we're not just comparing well and optimizing it just basing on MD or sections or runs. We are using the geology that has been interpreted within the offset wells and within the active well to scale the data properly between from the offset to the active wells, and then use that data to give you a more precise automated roadmap than over a bigger interval length.
Well, my question is there any mathematical modeling behind this roadmap?
Yes, so the mathematical modeling for the roadmap is based on how the total MSC was for when drilling the offset wells. So we have our own algorithm for calculating the MSC based on the
Okay.
BHA and sections put in, and we use that to basically determine the roadmap. So least MSC with the best ROP, the best ROP with the least MSC is taken as the roadmap, as the ROP roadmap.
But this is local, right? Just from this well or group of wells
Yes.
comparing to. It's not global. Is there any
No.
way to see this algorithm, or it's
It's on
proprietary?
it's on the back. Yeah, it's a proprietary on the back end.
So user can evaluate and decide whether he likes it, trusts it, or
So the
the
way our development works is that you can, it means, if you feel that this is not giving you the kind of roadmap you're looking, we encourage that, you tell us, that hey, what kind of, what exactly the discrepancy is, and then we can take it with the development team and bring more parameters into it to make it a more better roadmap, or maybe we include some other parameters and remove the MSC part as such. So the development is client based. It is based on the user feedback, but we would like to see it, see the what exactly the discrepancy is, so that the development can be more universal for everybody.
Got you. But is there any work, at least consider that, just to back it up with some mathematical modeling and maybe published models already in the literature, just to be able for your what is it, the program software, or it's really machine learning algorithm? Yeah.
No, it's a simple analytical workflow. It's not AI or machine learning. We do have a patent pending on it right now. And then we once, and we will look into having a white paper or a published paper on it.
Got you. Thank you very much. Appreciate
Thank you.
it.
Yes.
Tyler, please go ahead.
Hey, can you go back to that screen that is, hold on, where you're comparing like measured depth and TVD to your ROP and all that?
Mm-hmm.
Can you kind of point to each thing and what it is? Because I see there's it's very busy, so it
Yeah.
was kind of.
Yeah, just a second.
Yeah.
So over here, I'm showing you just the parameter like ROP, weight on bait,
Yeah.
RPM, and then this heat map over here. So let me zoom in a little bit more. Okay. And maybe I would change the scale a little bit. That might help. Yes. So the real-time trace that is coming from the VitsML source is in yellow curve.
Okay.
Let me switch out. Yeah. Okay. Okay, why is not this showing? Okay. Okay, there it is. Then you have the offset wells over here. Okay. And then you have the automated roadmap. And then looking at the lines, it can be pretty, it becomes pretty overcrowded. So we have this option to make it a heat map, to where now the same data is broken down based on the scales you have chosen. And then it puts the data along those bins to say, okay, 30% of the data falls between 185 feet per hour. And over here, it's like 20%. Here's like 26%.
Can you just like let it hover for a second so I can?
Sure.
On that ROP file, just looking at what the showing. So feet per hour. So where the cursor is on the drop stuff that's hanging down, what's the white and then the yellow? You said it says 160 feet per hour.
So yeah, the 160 feet per hour is the roadmap, which is based on the MSC calculations from the offset wells. So the expectations is that offset wells is like, okay, you should be looking at 160 feet per hour while drilling at 7420 as such. But in reality, you are getting 226, and the heat map is kind of giving you an idea that, hey, just looking at the data itself, without looking at the MSC and everything, you should be getting close to like about 185 feet per hour.
Gotcha. That's cool.
Okay.
Interesting plot.
Asim, will you take the question about the collision avoidance in the chat, please, from Oscar?
Yeah, are you guys trying to develop any for? Yes, absolutely. So going back to this. So all this ellipse of uncertainty that we are generating, it's based on the ISH, ISHWA guidance, and based on the provided MWD from like the magnetics sorry, what is that thing called? Magnetics model and tool code that we get from the MWD. These ellipses are developed. The coming workflow is using this ellipse to determine the anti-collision in real time, along with separation factors, C2C stats, and alerts based on that. Does that help you? And those are put right over here. So we have we can put our own, you can put your own magnetics code over here depending on what is been specified. And we have a multiple tool codes over here that can be chosen depending on the input that you get from the MWD as such. Did that answer your question, Oscar?
Yes, sir. Thank you very much.
Thank you.
Go ahead, Tyler.
Hey, can you go back through the sources of the data that you have access to, and also when you're comparing historic data, where, like, if we have Payson data or other data, TOTCO or whatever, where is that stored, and how do we like load offsets that are historical?
Yeah. So say let's say we have this plan well over here, and you can just select this add source. You can select the WITSML. Let me move this thing down. And then you can select, you can put your own connection name and anything. You can put your own WITSML server. So in this case, will be the Payson hub along with your login and credentials. It will give you the organization. And what we are doing, like what most of our clients are doing, is like for wells which are like historic. For Payson, it's pretty simple. They just restream the well, so it will start populating the data within the chosen well. So in this case, it will like being the planned well as such. And the data is stored on the Solo cloud. So it is part of the Solo organization. It is part of the subscription that you have for the Solo as such. And once the data is streamed in, it is for your access all the time. There is no time limit or anything like that. You can come down to it like 5 years down the road, 10 years down the road, and the data will still be there for you, as long as whatever was streamed in from the Payson side. So it is as simple as like, connecting it, then you can just select the well bore and then just start streaming as such.
I was asking like more if we have LAS files or things that have or spreadsheets. Is there a way to load that?
Yes. So we have our own. So here you can use the email parsing as such. But email parsing usually works for the depth logs. So you can add your trajectories. You can add your old historic logs as LAS file or Excel. It is already that email will be feed plus organization at ROGII.com. And you can just parse that data in to your Solo Cloud as such. If you want to bring in your time-based data, we have our own supports and service where we can help you push that data within your organization using an external application as such. Does that help?
Yeah, because I have all of our time-based data. So yeah, I just was wondering how that's done.
Yeah.
Thanks.
Yeah.
since there are no more questions, I want to thank all of you for your time today. It was great discussion, and thank you for the questions that you guys asked. On the screen, I'm sharing the contacts for our technical support team. You can email us or call us on these numbers, and our technical team will be happy to help you. If you're interested in watching a customized demo for DrillSpot, reach out to your account executives or the technical support team, and we will be happy to arrange demos for DrillSpot for you guys. So thanks a lot. I appreciate everyone for joining the call today, and happy drilling.
Thank you, everyone.
Thanks, guys.